Okay, test review. This is not a very long test. The f function equals x plus 5. The g function is x to the second power plus 1. So these two go in a matched pair. We got to find what f plus g of x is. So we put a plus sign and then we organize it into two quantities. The f function goes first, then the g function. Okay. Now we have to simplify using PEMDAS. So in the parentheses we can't simplify because we don't know the value of the variables. We're not going to know that. Power belongs to just CX. There's no multiplication or division. Add, subtract. Okay. So you have 1x constant, 1x second, and constant. So x second, x, and constant. So x second's 1. 1x is the constant, 5 plus 2 is 7. So now, into that composition, we put 3 in, 3 for x. Okay. So I go 1 times 3 to the second, plus 1 times 3, plus 7. I came up with 19 for that. Okay, f minus g of x. So I put a minus, and I put my f first, x plus 5, and then g, x to the power of 2 plus 2. So PEMDAS. So again, my parentheses can't be simplified. Exponents just to the x. No multiplication, division, then adding and subtracting. So we got 1, 1. Okay. I'm not a fan of that, make the minus plus and the quantity after it opposite, the whole quantity, not just the first term. So we have x to the second, x, and the constant. So we have negative 1, positive 1, and 5 and negative 2 make 3. Okay, so then I put 2 into the function. Okay, division's easy to set up. You just put the function f in the numerator because f's in the numerator, g's in the denominator, so it's x plus 5, then x to the second power plus 2. Okay. Then f divided by g of negative 4. It means I put negative 4 into the function for that. So we're going to have negative 4 plus 5. Okay, here's 1. And then negative 4 to the second plus 18. It's going to give me 30 plus 2. What am I doing? 18, 1/18. Okay, now for the dreaded input. So f input g of x. So remember what that means, input. So we start with the f function. You're going to want to put a 1 in front of the x. Okay, so you have a number to distribute. Now we input the g, which is x to the second plus 2. So now I go 1, x to the second plus 2, and then plus 5. Now start your operations to simplify. So parentheses, exponents, multiply, divide, add, subtract. So in the parentheses we can't simplify. Exponents just to the x, so that makes for an easy problem. Now multiply, divide, I would just multiply the 1, not that it changes it, but it would be 1x to the second plus 2 plus 5. Add, subtract, you just got x second, constant, constant, so I just go x squared and then constant, so it would be 1, 2 plus 5 is 7. I think I got that in an earlier problem, but that's fine. That's a 5. So f input g of x of 5, so equals x. So 1 times 5 to the second plus 7, I got 32. Okay, g input f of x, okay. So you start with your g function, which was the x to the second plus the 2. You're going to want to put the 1 as a coefficient in front of your x. so we don't get confused in the whole process. Go x is deleted and replaced with x plus 5. So now we have 1 parentheses x plus 5. The second power is outside the quantity, and then plus 2. So now we go here. Parentheses, can't do. Exponent, yes. Okay. And it's to a whole quantity, so we need to simplify that. Okay. So we're going to go down here, and we're just going to take x plus 5 times x plus 5. So x times x, x times 5, 5 times x, and 5 times 5. So that's x to the second, that's 5x, that's 5x, and that's 25. So that's 10x, okay? So 1, and then we put our x to the second, plus 10x, plus 25. Now the quantity, now the second power is inside, and then plus 2, okay? Now, exponent is now just inside to just the single variable. Multiply, divide, yeah, I need to multiply the 1 to the quantity, which really doesn't change anything when you multiply a 1 in there. It's 1x to the second plus 10x plus 25 plus 2. Then add, subtract. So we got x squared, x, and the constants. So it would be 1, 10, and 27. Okay, g input f of negative 2 equals x. So I put negative 2 in for the x. And I come up with 11. Okay, now find the two functions composed together to make f input g of x equals 4 times the quantity x minus 3 to the second power plus 6. Now, this is when you come up with two separate functions. So, the inner part of the function is x minus 3. So that's going to be our g. Then all we do simply is replace that with just an x. So we're going to have 4. And then if it's a parentheses, you can just write x to the second plus 6. Or you can put the x in parentheses. It doesn't matter, but make sure you put the second power and the plus 6. So that means if I did the input, I'd write the f down, parenthesize it, and insert x minus 3. Okay, f input g of x equals the absolute value of x minus 3. So the inside is x minus 3. That's your g, because that's the second one. Then I draw out my absolute value function, but then inside we just put x. Okay, find the inverse function of, remember how that works. You need to switch the x and the y. Then you need to isolate the y, okay? So we want y equals here. So over here I go x equals 8y minus 3. So y has operations of times 8 and a minus 3. So I get rid of the minus 3 with a plus 3. So we have x plus 3 equals 8 times y. Then we divide each side by 8. And now y is by itself. So it's just x plus 3 over 8. Okay, y equals 2x to the second power plus 7. So again, you swap out the x and y. Now we got to get the y by itself. So y has a times 2, a second power, and a plus 7. So we take out the plus 7 first with a minus 7. Then we get rid of the times 2 with the divide by 2. Then we take out the second power with a radical 2. That's the inverse operation of a power is a radical. Just like a radical, the inverse operation is a power. So we have x minus 7 equals 2 times y to the second power. Then I'm going to divide by 2. Then you can cancel the second power with a square root over the entire expression on that side with a 2. So it's a big square root, and inside I've got the quantity x minus 7 over 2. Okay, then the story problem, we don't need to do A and B before I read it. A store is selling very expensive items. On a day in March, sell any item for $20 less than the listed price. On any day in March, the store will give a discount of 15% to any customer who can prove that he or she contributed to a local charity. Okay, we want to write a composition so that the $50 off comes first, then write a composition so the 15% discount comes first. So we're going to use P as my variable because it's going to be the price paid. So first we look up our money. But this is wrong. It should say $20 off. Okay, not $50. It should say 20. So $20 less, so that's going to be minus 20. Then the percent is a multiplication. Okay, there's minus 20 here. They start off exactly the same. We just insert parentheses over the operation that comes first. Then I take 100%. Now if it's discounted, that would be minus 15%. That's 85%. So we're multiplying by 0.85. Because remember, P is the price paid, so the percent isn't the price paid. That's how much is taken off of what I pay. Okay, so 20 off first. And then the discount, the percent first. Okay, if an item costs $675, calculate the cost from each composition. So I'm going to write 0.85 times the quantity, 675 minus 20. Then 0.85, the quantity 0.85 times 675, then minus 20. So I take 675 minus 20, and that's 655. Then I find 85% of that. $556.75. Then here, $573.75, and then minus the 20, $553.75. So me as the consumer would want the percent applied and then do the discount, the $20 less.